Good morning, everyone. So for today's video presentation, we are going to talk about standard deviation, interquartile range, and quartile deviation. First, let's talk about standard deviation. Standard deviation is the most important measure of variation or dispersion. It is also the average distance of all the scores that deviates from the mean value. And it's also known as the square root of the variance. It is also known as the square root of the variance because when getting the standard deviation, we are just going to square root of the variance of a certain given data. So if you wanted to get the standard deviation, you also need to get first the variance. That is how we are going to solve the standard. That's how we are going to get the standard deviation. We are going first to the process of variance. Now the properties of standard deviation. Standard deviation is used when the data are in interval or in ratio level of measurement. So when we have seen that the data is in interval form, then we can use standard deviation when we are going to solve or when we are going to measure the central tendency of a certain data. Next, it is used when the frequency distribution is regular, symmetrical, or normal. Shows variation of the individual scores from the mean. Now, in getting the standard deviation, we have this formula. We have two formula actually. We have population standard deviation and sample standard deviation. First, the formula for population standard deviation, we have standard deviation is equal to square root of the sum of the difference between the mean and each score, between the total difference of the mean of the score minus its mean divided by the n, which is the total number of the given data. We also have the formula for sample standard deviation. We have standard deviation is equal to the square root of we have the total number of the difference between the score and each mean squared. So we're talking about a squared divided by n minus 1. That's all. These are the formulas for getting the standard deviation. Now we have also the steps in solving standard deviation. First, we need to solve for the mean. Then we are going to subtract the mean value from each score. Then we are going to square the difference between the mean and each score. Then we will find the sum of step 3. And we will solve for the population variance or sample variance and standard deviation using the formula of n-group data. So today we are going to focus on the n-group data. We are going to show you how to get the standard deviation using the n-group data. And if the variance is already solved, take the square root of the variance to get the value of the standard deviation. So if the given data have already given the variance, then we don't need to get the mean, subtract the mean. We are just going to straightly square root those variance, and then that's our standard deviation. That would be very easy if the data or if the table have already given the variance. Now we have an example here, a table for an n-group data. So the x there is our given values or the scores. Then the x minus x with the dot above is the difference between the between the score and its mean. So as you can see, in the table, it has already been given the mean, which is the 13. So in getting the negative 7, we are just going to subtract 6 to negative 13. So 6 minus 13 is equal to negative 7. And the rest will follow. That's how it was done. No? Then next, the third column shows the square root of the difference between the score and the difference of the score and each mean. So getting that, we just need to square this negative 7. Negative 7, square root of negative 7 is 49. Square root of negative 5 is 25. That is how it's done. Then after that, we are going to get the sum of all the scores. So it's total 213. And in the third column also, which is the square difference between the score and its mean, so its total is 186. After getting all that, since we already have the complete data for all, we can now start solving the standard deviation. So first we are going to get the variance. So this is the sample standard deviation formula. So we have here standard deviation is equal to the square root of the total score of difference of the score and its mean squared divided by n minus 1. So as we can see at the table, the total score of the squared of the sum of the squared differences of the score and its mean is 186. So we will put 186 here. The total number of the data is 10 minus 1, so 186. Now we will first solve 10 minus 1. So 186 divided by 9 is equal to 20.67, right? So then after that we are going to square root the 20.67 and the standard deviation is 4.55. So when we are going to interpret the result of the standard deviation, we need to follow or consider these two rules. If the value of the standard deviation is large, on the average, the scores in the distribution will be far from the mean. Therefore, the scores are spread out around the mean value. The distribution is also called as heterogeneous. If the value of standard deviation is small, the average, the scores in the distribution will be close to the mean. Hence, the scores are less dispersed, or the scores in the distribution are homogeneous. So as you can see in our example earlier, our standard deviation is 4.55. This means that since 4.55 is a low number, right? I think it's the value of standard.
Now, let's proceed to the interquartile range.
Because our
The interquartile range refers to the distance between the third quartile and the first quartile. The properties of the interquartile range is used when the data are in ordinal level of measurement,
means that the scores are homogeneous,
and it is used when the frequency distribution is irregular or skewed. It reduces the influence of extreme scores and considers only the middle percent of the scores in the distribution. It is not easy to calculate as compared to the range. To the point of dispersion of the scores is the median value. The formula of the interquartile range is equal to the third quartile minus the first quartile. When we need to interpret the result of the IQR, we need to consider these rules. The larger the value of IQR, the more dispersed the scores are from the median value, or the smaller the value of the IQR, the more clustered the scores from the median value. So in this table, when we need to get the IQR, we need to first find the quartile 3 and quartile 1. In getting the quartile 3, we have this formula. 3n divide into 4 is equal to 3 times 10 is equal divide into 4 is equal to 30 divide 4. The result is the 7.5 or 8. Therefore, the 8th number is our quartile 3, which is equivalent to 16. Next, let's find out the quartile 1. First quartile is equal to n divide 4 equal to 10 divide 4 is equal to 2.5 or 3. Therefore, the third number is our quartile 1, which is equivalent to 9. Now, let's get our IQR. IQR equal to quartile 3 minus quartile 1, which is equivalent to 16 minus 9 is equal to 7. Therefore, the 7th number is our IQR, which is equivalent to 16. And this means that the scores are more dispersed from the median value.
Now we are going to talk about quartile deviation. Quartile deviation refers to the average deviation of the third quartile and the first quartile from the value of the median. Properties of quartile deviation. First, used when the data are in ordinal level of measurement. Second, used when the score distribution is irregular or skewed. Third, reduces the influence of extreme scores. Considers only the middle 50% of the scores in the distribution. Not easy to calculate as compared to the range. The point of dispersion of the score is the median value. So in order for us to get the quartile deviation, we need to use this formula Quartile division is equal to third quartile minus first quartile divided by 2. Interpretation in getting the quartile division. The larger the value of the quartile division, the more dispersed the scores are from the median value. Or the smaller the value of quartile division, the more clustered the scores are from the median value. So, in this table, our first quartile is equivalent to 9 and the third quartile is equivalent to 16. So, in order for us to get the quartile division, we need to use the formula quartile division is equal to 16, which is the third quartile, and minus by 9, which is the first quartile, divided by 2. So, our quartile division for this table is equivalent to 3.5. Interpretation. It only means that the scores are more clustered from the median value.